Welcome to video series on operating system. Here we are discussing about memory management. In memory management, we are discussing about part 2. What is cache memory? Here we are discussing about the definition and explain the role of cache memory in improving system performance and discuss the types of cache L1 and their functions. Here the definition. A tiny and fast storage element called cache memory is positioned in between the computer's main memory and CPU in order to enable the CPU to access frequently requested data and instructions more quickly than if they were obtained from the slower main memory. It is intended to temporarily store their information. Here you can see the diagram of CPU to cache memory and main memory and secondary storage disk. Here you can see the pages transfer and block transfer and word transfer. If this word transfer and page transfer are exchanging to the CPU to word transfer are exchanging to CPU to cache memory and cache memory to CPU. And here cache memory to block memory, main memory to cache memory. Here you can see this is the position of cache memory system. And you can see the role of cache memory improving system performance. Cache memory's function in boosting system performance. System performance is enhanced by cache memory via cutting down on access time. Memory cache operates for quicker than main memory. The CPU can execute instructions more quickly by retrieving frequently used data and instructions faster from storage, minimizing latency. Because of RAM operates at a slower pace than CPU, there is a noticeable delay when the CPU access data from main memory because cache memory offers a fast storage region near the CPU, it's lower latency. Next one is increasing throughput. The CPU can execute more instructions in a given amount of time if it has faster access to data and instructions. This increases the system's total throughput, reducing main bottleneck. By reducing bottleneck both on main memory, slower read and write speed. Cache memory lets the CPU operate more effectively. Here you can see the cache memory schemes. Generally, there are three layers of cache memory: L1, L2, and L3. Every layer has various sizes and speeds, and then it's a different proximity to the CPU. Level 1 and cache memory of level 1 is the smallest and fastest kind because it is integrated with the CPU itself. It may function at the same speed as the CPU. Typically, the L1 cache is split into two sections: L1I, which stores instructions, and L1D, which stores data. This majority of software typically needs more caches for the data than instructions. Hence, the device accommodates the different fetch bandwidth utilized by CPUs. LPU cache normally has a capacity of, and here you can see the layer 1 example. For instance, where you are applying video games, the L1 cache stores important game command on often requested game data. This guarantees speed execution of game logic by the CPU, preventing the need for frequent data pulls from the slower memory and enabling the flow. You can see the here diagram of the layers of the cache memory, and here level 2 in compared to L1 cache, the L2 cache is marginally slower in speed but greater in size. It is always closer to the CPU than the main memory, regardless of whether it is housed inside or outside the CPU chip. Depending on the CPU design, the L1 cache may be exclusively to a single core or shared by several courses. Typically, L1 cache has a capacity of 256 KB to 512 KB. Example, let's say you want to edit a high resolution photo with photo editing software. The CPU can quickly access frequently used visual data by storing its L1 cache. The editing process is accelerated since the CPU does not have to continuously seek picture data from the slower. Here you can see the level 3 cache. Level 3 is also referred to as the last level cache. Is slower than the L1 and L2 but has a bigger capacity. It is shared by all cores and it is situated outside of the CPU. In inter-core connections and data sharing, the L3 cache is crucial, typical size of 1 to 8 MB. Every cache memory tier is essential for enhancing a computer system performance. These caches aim to speed up data access, times, and lessen CPU workload by holding instructions and data that are often different. We will examine the mapping and retrieval of data from the cache memory from the following sections. Examples: queries are being executed concurrently by many CPU cores on a server that is running the data applications. All cores can quickly access the data they need thanks to frequently used database tables and indexes stored in the L3 cache. The responsiveness, the performance of the database are prevented then in the share. Just to sum up, L1 and L2, L3 are crucial for boosting CPU performance. L2 cache fills the space between the L1 and main memory. L3 cache act as a shared resources in multi-core systems, and L1 cache provide quick access to important instructions and data. Together, these caches make it possible for CPU to access and processes data quickly, leading to more responsive and speedy computing experiences. Thank you.